Hello and welcome back to the chemistry lecture series. This is the second video in the topic of chemical nomenclature. In this video we're going to discuss polyatomic ions and really the rules for naming and in turn finding the formula for compounds with polyatomic ions. So what is a polyatomic ion? And the simple answer is a group of atoms and the key word there is atoms with a charge other than 0. And what I mean by that is, for example, one of our most common polyatomic ions is hydroxide, and hydroxide is OH. And if you look at a hydroxide, it's two atoms, an oxygen and a hydrogen, and they kind of hang out together. That you can treat them as if they were an element even though they're not. And it has a charge of -1. So this hydroxide polyatomic atom, or ion, excuse me, has a negative charge. And without that negative charge, these two don't hang out together. So you've actually got an oxygen hanging out with a hydrogen, and the hydrogen neutralizes one of the valence shells in the oxygen because they're bonded, but this other one still has an extra ion, so it's got a negative charge. Alright, so that's what a polyatomic ion is. It's a group of atoms that has a singular charge. And you can treat them as that because they don't tend to dissociate unless it's a decomposition reaction, which we'll talk about when we talk about balancing. So let's think electrically. You've got an NH4. This is an ammonium polyatomic ion. And actually, I've forgotten an M. Let's erase that. Ammonium. Alright, and this has a nitrogen in the middle and 4 hydrogen around it. Ammonia, which doesn't have 4 hydrogen and has 3, is a completely neutral compound. If you add this extra hydrogen, the ammonium has a plus charge. And that's kind of the whole gist of what's going on here. So here are some common polyatomic ions. You've got, and the ones you really need to pay attention to are ammonium, which is your only positive polyatomic ion on this chart. There are others, but this is the most common. Sulfate, hydroxide, phosphate, carbonate. A lot of these polyatomic ion names you've heard of. For example, ammonium hydroxide, which is bleach, or component of bleach. Carbonate, which is, actually sodium carbonate, which is found in pop. That's what gives it its fizziness. Peroxide, hydrogen peroxide, you know, the stuff you have in your medicine cabinet to clean out cuts. These are all polyatomic ions. They're just groups of atoms that have a charge. So how do these guys play when we're talking about naming? So let's look at one from each of the 3 types of binary, because you use the same rules. In our last video we talked about the 3 types of binary compounds: type 1, type 2, type 3, and what the different rules were. Well, these are polyatomic ions. Which means they have an electrical charge, which means you're only going to use the rules from type 1 and type 2. You will not have a molecular compound that has a polyatomic ion in it. It just doesn't happen because there's not a need to balance the charge in a molecular compound. So in a type 1 compound, let's say something with sodium in it, because sodium always has a constant +1 charge when it's an ion. Let's look at a different polyatomic ion. Let's look at acetate. C2H. H3O2. Sodium acetate, which is Na parenthesis C2H3O2. When you would write this, you just write the name of the cation and then the name of the polyatomic ion. And that's the long and short of it. If you look at a type 2 binary compound, for example, copper 2, let's see, 2, and then let's use hydroxide. All right, copper 2, same rules apply. Copper 2, because in this case the copper is a 2 negative charge, and then you just replace whatever your anion would have been with hydroxide, the name of the polyatomic. That's the long and short of it. The rules are the same, it's just we've inserted these polyatomic ions. The long and short of it. So, hopefully you have a better understanding of what a polyatomic ion is and how it interplays in the rules for naming compounds. We'll see you next time when we talk about acids.